Hello guys, welcome back to Ride On Academia. We are still on our series on the matrices, right? Now today we're going to be looking at the adjoint of a matrix, okay? Adjoint. The adjoint for 2 by 2 matrix, we are going to be looking at adjoint for 2 by 2 and 3 by 3, okay, for square matrices. Now, the adjoint of a 2 by 2 matrix is simply interchanging the principal element of the major diagonal, right? The element on the principal diagonal. Then we interchange the signs for the minor diagonal. I hope we still remember our principal diagonal and we still remember our principal diagonal, right, which is our main diagonal, and our minor. All right, now I said when we have an adjoint, okay, when we want to have an adjoint for a 2 by 2 matrix, okay, when we have a, let's assume this is our C, okay, this is set C. So the adjoint of our C, all right, the adjoint for C, all right, now we'll be having what? We'll be interchanging, okay, the first thing we're going to do, we're interchanging the element of the principal diagonal. Interchanging means this one will be coming down and then the one down will be coming what? Up. All right, now as well as interchanging the signs here is positive, okay. Since this one is positive, it means our sign for the adjoint to be negative, okay, but we're not interchanging these numbers, these elements, but the signs here have to change. So when we want to have an adjoint, the first thing we'll do that we're interchanging, okay, so these people are going to change places. So we'll be having 2 and then we'll be having 5. That's for a 2 by 2 matrix, okay. Now the next thing we're going to do is for the signs. All right, now our sign, like I said, here is positive, right? So we'll be having -1. We're interchanging the sign. Then here is also positive, so we'll be having -4. So this is adjoint for what? A 2 by 2 matrix. Now when we go to the 3 by 3 matrix, our adjoint is simply the transpose of cofactors. Now in our previous videos we have seen transpose, right? We have seen cofactors. In fact, we are going to be using the example from our cofactors video, okay, so that you'll be able to watch with us. Alright, so this is the example we have from our cofactors video, right? Now, like I said, the adjoint, what we do is that when we have gotten our cofactor, then we transpose, okay? So we will need to solve, okay? But since we've done the video on cofactor, I will not be solving cofactor. We'll be going straight to our cofactor deduction, alright? And then when we've gotten our cofactors, then they transpose with which is changing of rows, okay, into columns, right? We then transpose our cofactors to get our adjoint. All right, so from our previous video, right, our cofactor video, we are able to see that this was the cofactor we obtained for this matrix, right? So our adjoint for a 3 by 3 matrix, what we just do is that we transpose, okay. We have seen how to transpose, right? So we are going to be changing the adjoint of our C, right? We are going to be changing our rows into columns, right, and then our columns into rows. So this is our first row to become a column, okay. So we'll be having 12 -18 and -9. All right, now for our next column, our next row, which will become a column, right, we'll be having -4 and then we have 8. And then for our last column, we'll be having what? -20, 10 and -5. So we have successfully what? Gotten our adjoint, okay, transpose of our cofactors. That's for a 3 by 3 matrix. All right, so after we have solved for cofactor, then we transpose. Now we've come to the end of this series on adjoint. All right, don't forget to like this video, subscribe to our channel if you haven't, click on the notification button so that when new video drop, you'll be notified immediately. Also, don't forget to drop your comments to us on the comment section. We'll see you in our next class. Thank you.